In example 2, we're taking a look at two tables of data, table 24 and table 25 here. And we're taking a look at one table that will be a line or linear, and the other table will be an exponential function. Can you guess which would be which? Notice that in table 24, your values, even though your x is increased by 1 each time, your values are not reducing at a constant number. They're reducing at a multiple of a number. So you go from 162 down to 54. I don't know the difference, but notice down to 18, down to 6, down to 2. Those differences are different in each one. Where with table 25, you go from 0 to 4, but notice each time the y value changes, it changes by decreasing by 4. Now that would be a linear function. Next, let's go ahead and find the equation for each table of values. So table 24 is an exponential function. Let's find the equation of the formula. First of all, again, a is the y-intercept, b is the base multiplier. The y-intercept is very simple to find. It is simply set x equal to 0 and find the y value. So when you set x equal to 0, notice y is equal to 162, so that means our a in that equation is 162. Next, to find the b, the base multiplier, again, we go to a point, find out what the y value is, and then go to the 1 unit below that point and divide it, and we'll get our base multiplier. I think I'm going to just go to point 4 and find out that we have 2 for the y value. An x value of 3 gives us a y value of 6. Notice when I divide those, that gives me the base multiplier. Well, that would be 1/3. Notice it works for other numbers. If I would have started with the point x equals 3, y equals 6, and go backwards, then we would have 6 divided by 18. And all of these, of course, are equal to 1/3. So the equation in this case would be f of x equals a, which is 162. A lot of times they put the b in parentheses, so I'll do it this time. 1/3 to the x. So there you have the equation for that exponential function. Let's take a look at the other table. I wanted to go back to the data in table 24 and show you that you can double check the equation you come up with using your calculator. So let's do that. Real quick, all you would need to do is basically enter the equation into the calculator and then plug in the values 0 through 4 and see if you get the same y values out. So to plug in that equation here, I would just hit the y equals. Let me clear that out. Let me clear this one out just so that they don't get confusing. So it would be 162 times, now because of the order of operations, we actually ordinarily would not have to put the next thing in parentheses except for the fact that it is a fraction, so we need the parentheses. So 1 divided by 3 raised to the x. So once we have our equation entered, and I like to enter the enter key, now we can just go to table and enter those values. Now you'll see that I already have values. I can just type over the top 0, 1, 2, 3, 4. And notice, and let's see if I can, yep, we can just hit delete and get rid of those other ones. And notice that I do get the same y values, so that equation worked. Now let's find the equation for table 25's data. Again, because the y values decrease the same amount each time you move 1 unit in the x direction, it's going to be a line, a linear equation. Recall that a linear equation has the general form of y equals mx plus b, where m is the slope, b is the y-intercept. Again, same rule applies. To find the y-intercept, all you have to do is set x equal to 0. Well, you can see off the table when x is 0, y, or g of x, is equal to 50. So that tells me that the b in this formula is 50. Now to find slope, it's the change in the y's over the change in the x's, so I could use any 2 points. I'll use 46. I'll use 146 as 1 point, which would be 46 minus the y value of the other over the x, so it's the change in the y over the change in the x. The other point would obviously be x equals 0, y equals 50. So I'll put 50 here and 0 here. We get negative 4 over 1 or negative 4. Notice that slope, even though it's the rise over run, by definition, basically each time you move a unit, which just means by an x value of 1, each time you move 1 unit, that will be your slope or your change from point to point. Therefore, the equation would be, well, I guess it's g of x, so I should write that. G of x equals, the slope was negative 4 and the b was 50. Again, you can double check your answer either by using table or just plugging in numbers. For example, when x is 0 here, I get 50 out. When x is 1, I get negative 4 plus 50, which is 46. When x is 2, I get negative 8 plus 50, which is 42. So you can easily double check that.